Good morning, y'all. I just drank my coffee, watched MOP interview on this way in the morning. And now it's time to get smart. I learned something new. I learned how to graph. Like I can just graph using a graph calculator. I can graph a function, and I know some stuff. I know some stuff about how to take derivatives, but now I can just fiddle with it right there and watch if it kinda makes sense. For example, this one right here. You can see that around 0, if you take the limit around 0, you see that the derivative goes to infinity. So like the slope goes to infinity. It's vertical. And you can see there that the derivative is asymptotic. The value goes to infinity right there of the slope. So yeah. So if we would take the second derivative of this, what would it happen? Because the slope of this, whatever, the slope of this is negative infinity. Yeah, it's negative infinity, whatever. Yeah, so I can play with it and test if I was right. But it's a bit cheating because I should be able to do this shit without a graphing calculator. So maybe I should write my own graphing library, graphing program for it to be fair. That goes. Like if I write it myself, it goes. It's not cheating. Yeah, maybe I should do that tomorrow. For sure. So, I'm done with Khan Academy for today. I did learn something new. I did practice my skills. Now I gotta get down with writing, and today is bar day. I gotta write bars. And afterward, I'm doing Project Euler. You know what? I want to include something else in this workout because it's really important to me. It's tensor calculus, and if I can do tensor calculus every day, that makes it certain for me to succeed. And like Khan Academy doesn't have tensor calculus. I think it has some form of vector calculus, and that's gonna brainwash me into losing geometric insight. And I guess the antidote to this effect would be to follow tensor calculus lectures every day. If I do that, I'm gonna be good. So I'm gonna include tensor calculus after writing, because I want to have that clear ending to my workout schedule. Like I do Khan Academy, it's fuzzy because I can do more or less, blah blah. I can do writing, I can write less or more, and then I can do the lectures. I could go further or least far. But I finish with Project Euler, and Project Euler is like bam, you got the answer, so it's done. Now you can go on, do your work. You done the work. You done the mental workout for today. You're cool. So yeah, now it's writing. That's the next thing. Okay, so bars. Let's take this and this. And my coin. And let's see. The first word is torment. Right here. The able-bodied young man theory. What should I take? Should I take able-bodied young man? Should I take man? Or should I take theory? I'm gonna take able-bodied young man. I gotta correlate torment with able-bodied young man. Let's see how it goes. It's a bit corny, but yeah, who gives a fuck? Now we on to tensor calculus. Tensor calculus is what we do next. Okay, I gotta keep the camera charging because it doesn't have enough battery. I did something like I just learned that the dot product of two vectors, so u dotted with v, is equal to the magnitude of u times the magnitude of v times the cosine of the angle between them. This is gamma? What the fuck? Gamma. Okay, that's u. Okay, times the cosine of gamma. So it's like this. Yeah, the angle between them.
That's an ugly gamma. And I just read that this is also called projection product, because as you can see, the cosine is the adjoint cathete to the angle over the hypotenuse. So when the angle is 0, you get 1. So you get full. When the angle is 0, you get the full thing. You get the full multiplication of the magnitudes. When it's 90 degrees or p divided by 2 radians, it's 0. So that's why it's called projection product, because you actually project. You actually project in this direction that vector and you get 0. So when you multiply it, it gets zeroed out. And apparently mechanical work, I don't know what it is, but I'm gonna learn, is the dot product of force and displacement. Magnetic flux is the dot product of the magnetic field and the vector area. These things don't tell me much right now, but yeah, I guess that this thing is enough for now for the vector calculus. This doesn't really pertain to vector calculus in particular. This is like basic vector algebra or vector arithmetic. This is vector arithmetic. So I'm gonna write it here. Yeah. The reason why I'm going so fast is that I wanna do the project Euler problem, and I thought of something. I didn't include assembly in my programming language wheel. So I think instead of doing HDL now, I'm gonna do assembly now. I'm gonna do assembly today, and I'm gonna take C++, which was a hard language, and I'm gonna put it in the category of an easy language, and then I'm gonna put HDL at the end or in between. I don't know. Regardless, I'm gonna add assembly instead of HDL and put HDL to the bottom of the list, or just before C++, I think. Yeah. So let's see if I can learn enough assembly today to solve a project Euler problem. I'm not sure if I can do it, because I also have something else which is more important to do, which is more important for me to do, which is do some CGI, like I explained yesterday what that's about. Actually, I think I'm gonna postpone the assembly project Euler problem, and I'm gonna do the thing that I wanted to do, the CG stuff, and afterwards I'm gonna edit the video from yesterday. I'm gonna do the CG stuff, and afterwards I'm gonna do the problem, and afterwards I'm gonna edit the footage from yesterday, post blah blah blah, and see if after all this I still have time to segment the tarsal group from the CT scan that I got, the Melanix CT scan. So yeah, let's see.
Yo, I finished the CG tulip I was doing for Mother's Day. Took me a few hours and recorded the whole thing. A screen recorded the whole thing. Now I really gotta render my vids, my yesterday footage. I gotta edit and post it, and then if I still got time, I'm gonna do my assembly problem. Hopefully. I like how the tulip ended up. It's pretty cool. Yeah.